All right, today we're going to dig into something pretty cool, a really fascinating connection that a sixth grade math curriculum pointed out. It links a problem-solving method that's thousands of years old with the kind of algebra you'd see in class today. So how on earth did they connect? Let's find out.
I mean, seriously, look at this. On one side, you have an ancient Egyptian ruler's totally confusing dream, and on the other, a multi-step equation. What could they possibly have in common? Well, it turns out they both represent the same kind of challenge, a complex problem that feels unsolvable until you find a clear step-by-step process.
So let's jump back in time to the ancient side of this puzzle. In the book of Genesis, there's this story about Joseph. He gets brought in front of the Pharaoh, who's been having these two really troubling dreams that none of his advisors can figure out. And this wasn't just some small worry. The fate of the entire kingdom was literally hanging in the balance. We're talking high stakes.
Now, Joseph's response here is what's so interesting. He doesn't just pretend to have a magic answer. Instead, he points to a source of wisdom, a reliable process for finding clarity. He understood that to solve a huge problem like this, he needed a method to interpret the information and uncover its hidden meaning.
And that brings us right back to our modern puzzle. When we face a complex equation, we also need our own kind of wisdom, a toolkit of reliable rules and methods that help us get to the solution. So, just like Joseph, we need a process. You can't just wing it.
The most powerful tool in our entire kit has got to be inverse operations. You can just think of them as opposite actions or undo buttons. Addition undoes subtraction, and multiplication undoes division. This is absolutely the key to peeling back the layers of an equation to find out what x is hiding.
And of course, there's our old friend PEMDAS, the order of operations. This is our guide for simplifying things. But here's the twist. When we're solving for a variable, we often use these ideas in reverse to carefully undo the problem, one step at a time.
All right, with our toolkit ready, let's put on our detective hats and decode our first equation. We're going to apply these concepts to break down the problem and reveal the answer that's hidden right inside.
So here it is, our puzzle. 2 times the quantity of x plus 3 equals 16. Our mission, should we choose to accept it, is to get x all by itself and figure out its value. We're not going to guess. We're going to use our inverse operations to work backward and reveal the solution one clue at a time.
Okay, first let's look at the outside of the parentheses. That whole group, the x plus 3, is being multiplied by 2. So what's the inverse of multiplying by 2? Dividing by 2. And remember, whatever we do to one side, we have to do to the other to keep the equation balanced. So we do that, and it simplifies right down to x plus 3 equals 8. Just like that, the problem is already much simpler.
Now we're just one step away. X has 3 being added to it. The inverse of adding 3 is, of course, subtracting 3. We do that to both sides and bam, we've isolated our variable, we've cracked the code.
And there it is, x equals 5. See? We didn't need to guess or do anything magical, we just followed a solid, step-by-step method to uncover the answer.
And you know, the best part is that this isn't a one-time trick. This logical pattern, identifying an operation and then applying its inverse to both sides, is a universal strategy that you can use to master all kinds of equations. Just take a quick look at these examples. Notice the pattern in the key first step column. In each case, we're identifying the operation that's kind of loosely attached to the variable and undoing that first. For 2x plus 5, the addition of 5 is undone before the multiplication. For 3 times the quantity y minus 2, the multiplication by 3 is undone before we deal with what's inside the parentheses. This strategy of working from the outside in is the real key to mastering these puzzles.
So let's just zoom out for a second. We started with an ancient dream and ended with a modern math problem. The common thread here, the big idea, is that breaking down large, confusing problems, whether they involve algebra or not, into small, manageable steps is an incredibly powerful skill for life.
So I'll leave you with this final thought. When you face a big challenge, maybe at work, at home, or with a personal goal, how can you apply this same logic? How can you identify the core issue and then work backward, step by step, to find your own solution? Turns out, it's a method that's as timeless as it is effective.